All right. Okay, is everyone looking at number 1? Remember, the goal is not to race through this. We're going to talk about each little thing, every little thing, because you got to be able to do proofs. Right? Okay, focus. That means everyone get their head off their desk. Heads off their desk. I know you guys like afternoon naps.
I vision.
Fisher likes afternoon naps too.
I vision.
Oh my gosh, I love that.
Okay, so take a look at this. Now when we do the OST, most of the time the proofs are drag and drop, which means they'll have like a bank of choices down next to it or underneath it where you have to drag the stuff into the proof wherever it goes. Now remember, when you do a proof, there's more than one way to do a lot of proofs. The problem with these is you can't do it any old way you want. You have to follow the pattern that they do, which is sometimes harder than doing it all by yourself, right? So, how many answer choices do they have at the bottom of this proof? Count them up. How many options do you have?
1, 2, 8.
There are 8 of them. How many blank spaces do you have in the proof? 4. So we have 1, 2, 3, 4 spots. So clearly we're not going to be using all of them, okay? We're not going to be using all of them. But here's some clues to give. Now, first thing, you should be able to read your givens and fill in your picture or draw a picture. So let's start with that. Okay, so grab a color. Grab a color. Remember, we're going to spend 15 minutes on this one proof. So don't worry about moving on because I'm going to point out some other things. Okay, got a color?
Really got like orange.
I picked orange. Okay, so the first given is right here. We are given that the measure of angle 2 is equal to the measure of angle 3. So let's go to our picture and find angle 2 and angle 3, and let's mark them so that their measures are the same. So does everyone see angle 2? Okay, I'm going to mark him with an arc and a little ticky-ticky. And then I'm going to just mark 3 exactly the same way, with an arc with a little ticky-ticky. Okay, that is my first given. That is the only thing they give me. So the only thing they do is they give me that one statement, and then they give me a diagram, so I can get stuff from the diagram probably, right? Cool on the first step? And that's the very first thing they stated right here. They said the measure of 2 is the same as 3, and they said that that's given. So this first line looks awesome. He's all done, okay? We marked it in the picture. Nothing looks weird yet, right? Okay, so I'm going to move to a new color for the second step. So, a new color. I'm going to go green for this step 2. Okay, so step 2 says the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so let's go to our picture and find the measure of angle 1 and 2. Where are those at? Are you with us? They're right here. 1 and 2. You see those two? It says that they make 180 degrees. Do you guys agree with that? Okay. What?
So yeah, yes.
True. But what is the reason for it? Yeah, remember when it is a half a pizza. Is this a half a pizza? Half a pizza is which one of those options? Linear pair. So that's a linear pair. Now let's just, before we write it on our line, let's go check the second half of number 2 and see if he's also the same thing. So the second half says angle 3 plus angle 4 is 180. So I'm going to find that in my picture. 3 plus 4 equals 180. Are those also a half a pizza?
Yeah.
Okay, so both of those are linear pair. So it's safe to say that number 2 is linear pair. Okay? I would always do these in pencil because they're kind of like a puzzle. And so sometimes you think something might fit and then you realize that they went in a different direction than you thought, so you might have to erase. So this is a linear pair. Okay, cool.
I guess what I wanted. But I want.
Okay, you ready to go to step 3? Okay, step 3. I'm going to go pink. Okay, so let's look at step 3. So let's look at it and see if it makes sense first. So step 3 says that 1 plus 2 is equal to 3 plus 4. So look back in your picture. 1 plus 2 is equal to 3 plus 4. Does that make sense?
Yeah.
Okay, it does make sense. Now we need to figure out a reason. You guys are not going to know how to do this if you're not focused, I swear. You're not. We're going to have to look down here at our options and see if anything stands out. Well, let's do something else. Let's try another strategy. Can we do some elimination? Okay? So I'm just going to put a pink dot by the stuff that I know is not even possible on this line. Okay, so we do know that 1 plus 2 is equal to 3 plus 4. You told me you agree, right? So let's just look at our choices down here and see which things make 0 sense at all. So 1 plus 2, 3 plus 4. Does subtraction property make any sense?
No.
Have they been doing any subtraction?
No.
Did they subtract anything above it?
No.
No. So probably, I'm going to put a little pink X because we might use this for something else, but we're definitely not using it for this line. So vertical angles. Do you think 1 plus 2 and 3 plus 4 have anything to do with vertical angles? There's no across from the X. So we know vertical angles is off the table, right? Let's look at this. Consecutive interior angles are congruent. When are consecutive interior angles congruent? When you have parallel lines. Tell me about this picture. Are there any parallel lines? So literally, this is like off the table automatically for every single thing in this problem because there are no parallel lines at all. So don't even think about using him for anything. You know what I mean? So we are down to a few things. And it looks like we need reasons over here. Is this the measure of angle 1 plus, is this a reason?
No.
Is this a reason?
No.
No. So what are the only 2 possible things that could have happened?
Substitution.
Substitution or the definition of congruent angles.
I think it's the definition.
Okay, so it can't be the definition of congruent angles because we don't even have congruent angles mentioned above here anywhere, do we? And is 1 plus 2 an angle? No, we would have to be naming like the whole straight angle. So he's really not going to fit there. Here's the deal. This guy, everyone wants to use him all the time. And in reality, he hardly ever gets used. So stop wanting him to be an answer because he's usually not. I purposely put a couple on here that do have this as an answer, just so you can see what it looks like when you do have to use that. It actually is substitution. So could someone explain why, if you thought it was substitution, can you explain what you think they substituted?
Saying so the 2 things are equal, you can sub one property to the other. So then it just be sub out the 2 with 3, and that proves that it's 1 equals 4.
That would be the next line. Why was this line substitution? What did they, like, look at this line. Doesn't it say that this 1 and 2 make 180, but also 3 and 4 make 180? And so, yeah, so they basically took this, can't they just take this 3 and 4 and put it right here in this 180 spot? Because they both equal 180. So that's how they got substitution on that line. Okay, and now let's talk about what Amir just was talking about. Because the next line, focus, the next line, the answer is substitution. So they're about to do some more subbing, okay? So you need to look at this line. I'm going to do this one in blue. You need to look at this line and think about if any of these things could have a sub. Now remember, a sub means that they've already told you above somewhere that they're the same. So look above here. What have they told you is the same up above here?
2 and 3.
2 and 3 are the same. So that means that wherever you see a 2, you can pull him out of the game and put a 3 in his spot. Also, the other way around. Wherever you see a 3, you can pull him out of the game and put a 2 in his spot because they are equivalent players, right? So if you look at this line, so they must be doing some kind of subbing. So they must have either subbed a 3 into the 2 spot or a 2 into the 3 spot, right? Those are the only 2 subbing situations that are allowed to happen. The other thing I wanted to point out, look at the bottom here. Heads off the tables. Down here, remember 1 and 4? You need 1 and 4 in the game at the end, right? So that should tell you that don't mess with 1 and 4 because they got to stay in the game. You know what I mean? So sometimes there'll be more than one thing that's possible. Like right now, there's more than one thing that's possible. I could sub in a 3 where the 2 is, or I could sub a 2 in where the 3 is. Or both, really, right? But sometimes the possibility will be to sub for the 1, but if you look down here, we want 1 to stay in the game. So that will be another clue to not mess with the 1 and the 4. Okay, so look at your choices. And which sub did they pull off? Did they do this one or this one?
The first one.
The first one. Do you see how they took, let me write it right underneath it so then you see it. They kept the M1 plus, they put M3 equals the measure of angle 3 plus the measure of angle 4.
Wouldn't all those angles be added together be 360?
Yeah. So they have subbed, they took the 2 out of the game and put the 3 in the spot. So they have used this one down here. And the last step. They say that angle 1, the measure of angle 1 is equal to the measure of angle 4. What are our options? Is it the definition of congruent angles? No. The definition of congruent angles says 2 angles with the same measure. Do we know the measure of angle 1? Does anyone know the measure of angle 1? No. Does anyone know the measure of angle 4? No. You don't. You know it's something that can add to the other one to get 180 because that could be lots of numbers, right? So you actually can't use this. You cannot use the definition of congruent angles because the definition of congruent angles is angles that have the same measures. And we don't know anything about angle 4 and 1 as far as numbers go, right? But what else have we not used? Yeah, vertical is not in this picture, so that he's off the table, right? But we have this subtraction property. So subtraction property of equality says that they took an equation and subtracted the same thing from both sides. So look at the line above it. What can you subtract from both sides of this equation? You see this? Minus the measure of angle 3 and minus the measure of angle 3. That's subtraction, property of equality. And what will you end up with?
Measure angle 1 equals measure angle 4.
Which is what they did. So they did do subtraction, property of equality. Subtraction, property of equality. And this was one of the easier ones, for the record. Okay, so here's the deal. Take this paper. You can tuck it into page 20 where all the other ones are, or you could tuck it into your spiral where you're working on the worksheet. Either one is fine.